The accident at the fourth unit of the Chernobyl nuclear power plant destroyed the reactor core. At the time of the explosion, no one fully understood the consequences of the massive release of radiation into the environment. So it was decided to build a concrete sarcophagus around the fourth unit to completely enclose the damaged reactor. But the question of what remains beneath the sarcophagus still intrigues many people, even years later. Many remember the story of the helicopter that crashed directly into the area of the future structure. The crash occurred on October 2, 1986, while the crew was working on treating the roof of the reactor blocks. In 2017, during dismantling work on the roof of the turbine hall beneath the sarcophagus, the wreckage of that helicopter was discovered. However, beyond the helicopter, the sarcophagus conceals many unsettling facts. For example, many people do not understand what caused the deterioration of the structure and why it is dangerous. To understand what is happening to the sarcophagus, it is important to know how it was built and what took place even before its construction. In the first days after the accident, efforts were focused on reducing radioactive emissions from the destroyed reactor and preventing even more serious consequences. For example, there were concerns that residual heat from the fuel could cause a meltdown of the reactor core. The molten material could have penetrated the flooded rooms beneath the reactor and triggered another release of radiation. Measures were also taken to prevent the melt from seeping into the soil beneath the reactor. Within a month, miners dug a 136-meter tunnel under the fourth unit. It became clear that without extinguishing the fire inside the reactor and sealing it, it would be impossible to carry out work on the ground. Therefore, hope was placed mainly on the pilots. Few people now know that one proposed method to extinguish the reactor fire at the Chernobyl nuclear power plant was to run a hose from the Pripyat River, attach it to a helicopter, and pump water directly into the reactor. Fortunately, this idea was abandoned. Instead, even before construction of the containment structure began, helicopters started dropping materials into the reactor shaft to reduce emissions and localize the source. On the first day, 45 flights were carried out, and by May 1st, the number of flights had increased 15-fold. Just imagine, over 2 weeks, more than 15,000 tons of materials were dropped onto the fourth unit, including nearly 7,000 tons of lead, about 3,500 tons of marble chips, 2,000 tons of sand, and many other substances. The first sarcophagus over the destroyed fourth unit was built at the cost of the lives and health of nearly 100,000 workers in an incredibly short time. The entire construction took just 206 days from the moment of the accident. It was built in haste to prevent the spread of radioactive materials across the world. According to scientists, more than 80% of the radioactive construction standards were not fully followed in every aspect. For example, some of the supporting beams were simply resting on the debris of the destroyed reactor, and parts of the roof were covered with large pipes that were not even secured. During the construction of the sarcophagus, load-bearing supports and the main beam had to be placed on structures damaged by the explosion, whose strength could not be reliably determined due to extremely high radiation levels. All floors, roofing, and stairways were decontaminated, then reinforced, and additional structures were built. This made it possible to prevent radioactive debris from being carried outside. Most of the hazardous fragments remained inside. If you think the sarcophagus is just a large concrete box, that's not the case. It is a complex engineering structure that was essentially designed on the fly. Nothing like this had ever been done before in global practice. From 1986 to the present day, no more than 60% of the Pomyshchenyi premises inside the containment structure have been explored. The remaining 170 rooms are inaccessible due to extremely high radiation levels, or because of impenetrable barriers created either by the explosion or during the concrete pouring by the builders of the sarcophagus. This unexplored zone now represents the main risk posed by the destroyed fourth unit. While the sarcophagus was being constructed, reconnaissance and diagnostic work were carried out inside the damaged reactor block. Contrary to expectations, neither domestic nor foreign robots were able to operate effectively among the debris under such intense radiation conditions. If the robots didn't fail immediately, they got stuck in unsuitable places or stopped functioning altogether in strong radiation fields. As a result, humans carried out the reconnaissance. The workers managed to walk, crawl, and often run through many of the reactor's rooms, installing permanent monitoring instruments there. They did not observe any melting through or destruction of floors on the lowest levels, which meant that the so-called China syndrome was not occurring there at that time. To clarify, the China syndrome is a reference to a film about an accident at an American nuclear power plant, where reactor fuel melted through concrete floors and began burning its way deep into the ground. Even today, beneath the original sarcophagus lies the exploded fourth reactor, along with a vast amount of radioactive materials and debris that were dumped there by cleanup workers from the roof of a nearby building at the plant. It turned out that only a small portion of the reactor core fragments remained in the reactor shaft, while the upper biological shield, the reactor lid, weighing more than 2,000 tons, is tilted at about a 15 degrees angle. On one side, it rests on the edge of the metal vessel, and on the other on a reinforced concrete slab lying across it. Numerous torn technological pipes hang down from it. The lower part of the reactor structure sank about 4 meters after the explosion, crushing a massive cross-shaped metal structure in the space beneath the reactor, and roughly a quarter of it was completely destroyed. At the base of the reactor, there is a pile of graphite blocks, structural elements, and newly poured concrete that also filled the subreactor area, where a significant portion of the fuel ended up. According to some data, only about 5% of the radioactive materials were released into the atmosphere, while 95% remained buried within the destroyed reactor. When cleanup workers reached the corridor beneath the reactor in 1986, they encountered a solidified black lava-like mass. After the explosion and the failure of the cooling system, the reactor core essentially melted down. Streams of radioactive lava flowed through pipes, melting concrete and steel. As a result, formations resembling stalactites and stalagmites appeared, one of the most famous being known as the elephant's foot. After this formation was discovered, another alarming fact became clear. It is impossible to remain near the elephant's foot for more than a few seconds due to the extremely high levels of radiation it emits. Moreover, it continues to generate heat and slowly melt the concrete beneath it, gradually sinking deeper into the ground. This could potentially lead to further contamination if it reaches groundwater. The hastily constructed sarcophagus contained the spread of radiation from the reactor for about 30 years. However, its structures and walls began to deteriorate. In 2013, sections of the roof panels over the turbine hall collapsed. Due to the lack of proper sealing, moisture was able to enter the sarcophagus in large amounts. Under the influence of moisture and temperature fluctuations, the fuel-containing materials inside the sarcophagus have been degrading, generating large amounts of radioactive dust with high concentrations of long-lived transuranic isotopes, including plutonium-239, which has a half-life of about 20. According to even the most conservative estimates, at least 1,000 tons of such dust have already accumulated. The original sarcophagus has another serious drawback. Its design does not allow for proper handling of the radioactive waste that has built up inside. Until all the contents of the damaged reactor are removed and safely disposed of, the site will remain hazardous. The potential collapse of the old sarcophagus means that multi-ton slabs could fall onto the reactor, lifting radioactive materials into the air. These particles could then settle on the inner walls of the new arch-shaped containment structure, turning everything inside into a massive source of radiation. Did you know that 2 different sarcophagus designs were originally considered? The first proposed building a completely independent, fully sealed structure of enormous size around the reactor, either an arch with a span of about 230 meters or a massive dome. In other words, something similar to the large arch that now covers the site. The second design proposed making maximum use of the remaining walls and structures of the destroyed reactor block. The new walls and roof would be supported by these existing elements. Calculations showed that the first option would take about 1.5 years to complete and require enormous costs, while the second could be finished in just a few months and at significantly lower expense. Naturally, the second approach was chosen. It allowed for major savings in both time and cost, which is exactly what was done. The price of that decision was not only the massive collective radiation dose received by the builders and installers, but also fundamental flaws in the structure itself. For many critical structural connections, welding could not be used, and remote installation made it impossible to precisely fit large metal components together. High radiation levels and debris prevented a proper assessment of the strength of many supports that had been damaged by the explosion and fire. Yet these very structures were used to support the main load-bearing beams of the sarcophagus. The use of remote concrete pouring methods led to large amounts of concrete not reaching their intended locations. Instead, it flowed into the damaged building, making access to many rooms difficult or completely impossible, and hindering further inspection and exploration. In the official conclusion on the reliability and radiation safety of the Chernobyl sarcophagus, presented by a government commission on October 11, 1986, it was stated, "The characteristics of the shelter object are defined by its potential hazard, which significantly exceeds what is permitted by the standards and regulations for facilities containing nuclear and radioactive materials." The situation is further complicated by the fact that safety assessments for nuclear and industrial facilities are usually based on operational experience with similar structures. However, the shelter has no real equivalent. This means that as early as 1986, immediately after its construction, experts had already concluded that the sarcophagus was unreliable. Simply put, for all these years it has been standing largely on borrowed time and could have collapsed at any moment. This risk was even greater considering that parts of the reactor building in the western section, the wall has deviated by up to 50 centimeters, and fractures have been recorded in some areas. In such a condition, the problem is that the technology capable of operating under such extreme conditions still does not fully exist, and unlike in 1986, no one will send in large numbers of workers to face those risks again. As a result, the sarcophagus continues to conceal many vulnerabilities that could potentially lead to serious consequences. Moreover, as we now know, the sarcophagus itself was built directly on the ruins of the fourth reactor unit, and the entire structure could collapse at any moment.